Hello guys, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem. It says that determine the tension developed in three cables required to support the traffic light which has a mass of 15 kg, and it is said that take h equals to 4 meters. So here this knot is at a height of 4 meters from the ground, or we can say that it is at a height of 4 meters from the road. So we have to find the tension developed in each cable. So now let's say that the tension in cable AB, the cable which is acting from A to B, is, let's say, T1. Let's say that the tension in cable AB is, let's say, T1, and the tension in cable AC is, let's say, if this in this cable, let's say this is T2, and similarly in the third cable this is, let's say, T3. So we have to find T1, T2 and T3. So first of all, I will represent this T1, T2 and T3 as a Cartesian vectors. So as we know that T1 vector, this will be equal to T1 magnitude times the unit vector from A to B, since T1 is acting from A to B. And now we know that the unit vector from A to B is, we can write that this is T1, and the unit vector from A to B is the position vector from A to B divided by its magnitude. So now this is T1, right? So T1 magnitude and multiply by the position vector. So this remember that this h is 4 meters. So to find the position vector for T1, what we need to do is that we need to move along the x, y and z from A in order to reach this point B, since T1 is acting from A to B. So now from A we need to travel 4 meters in the negative z direction. This is the positive z direction. This is the positive x, this is the positive y. So we need to travel 4 meters in the negative z, or in the negative k direction. So I will write here is minus 4k. So when we travel 4 meters in the downward direction, we will reach the ground, and then from the ground we need to travel 4 meter distance. This distance is 4 meters. So from this point we need to travel 4 meter distance along the positive y. So that is plus 4 along the j direction. So from A, this distance, and then 4 meters, and once we travel 4 meters, then we need to travel this distance along the positive x. This is the positive x. So this distance is 3 meters. So this means that we need to travel plus 3 meters in the positive I direction. So now once we reach here from A, this distance, this and this, we will reach the base of this pole. So again, to reach that point B, we need to travel 4 meters, since the height of the pole is 4 meters. So this is 4 meters in the positive k. So I will write plus 4k. So if we look into this, so this is 4k minus 4k plus 4k, so this will give us 0k. So we can write that this is 0k. So this is plus 3i plus 4j plus 0k. So now from this position vector from A to B, we can conclude that this AB cable is horizontal. It is in the xy plane. So A and B are at same height. Since this is h is equal to 4 meters and the pole A is of height 4 meters, so that is why we have the k component of the position vector equals to 0. So then we have to find the magnitude of this position vector. So the magnitude will be 3 square plus 4 square plus 0 square under the square root. So this T1 vector, this is equal to T1, and the magnitude is 3 square plus 4 square plus 0 square, so that is 5, right? So we can say that this is t1 divided by 5, or we can say, let me write this as t1 divided by 5 multiplied by this position vector. So now we need to multiply this ratio with each component of the position vector. So this will be, we can write that this will give us plus 3 divided by 5 t1i plus 4 divided by 5 t1j plus 0k. So this is the Cartesian vector representation of the t1, which is acting from A to B. Now we will find the Cartesian vector representation of t2. So now t2 is equal to, again we need to write t2 as a Cartesian vector. So t2 magnitude times the unit vector from A to C, since t2 is acting from A to C, and this is equal to t2, and the unit vector from A to C is again the position vector from A to C, and then divided by its magnitude. So now this is equal to t2 and the position vector from A to C. So now we have to find the position vector from A to C. We can repeat that same method by traveling along x, y and z to reach point C from A, but this time we will find the position vector by applying one another method. So this time we have to find the distance between point A and C, or the gap between point A and C along the x, y and z axis. This is one another method to find the position vector between any two given points. So now the distance between point A and C along the x axis is this distance, right? This pole is at a distance of 6 meters from this particular point. So this means that the distance between point A and C along the z-axis is 6 meters. So from A, we need to travel 6 meter distance in the negative x direction. So we can write that this will be minus 6i. Similarly, the distance between point A and C along the y-axis is 3 meters. Since this point, which is the projection of point A, is at a distance of 3 meters from the base of this pole, which this base is the projection of this point C. So the distance between point A and C along the y-axis is 3 meters. And as we can see that from A, we need to travel in this direction to reach that point C. So this direction is the negative y direction. So we can write that we need to travel 3 units in the negative j direction to reach that point C. Now in the z direction, as we can see that point C is at a distance of 6 meters, or we can say that point C is at a height of 6 meters and point A is at a height of 4 meters. So this means that point C is 6 minus 4 meters away from point A in the z direction. So we can say that we need to travel 2 meters from point A in the z direction to reach that point C. So this means that the gap between point A and C along the z direction is 2 meters, that is plus 2. So plus 2 in the positive k direction. So again, if we repeat that method, so we can get the same position vector. So if I repeat that method, so along first from A we need to travel minus 4 meters in the negative k, that is in the downward direction. So let me write minus 4k. Then we need to travel this distance. So this distance is in the negative x, 6 meters in the negative I. So I will write minus 6i. And then from here we need to travel this distance. This distance is 3 meters. This is in the negative j. So I will write minus 3j. And we will reach here. So from here we need to travel this distance 6 meters in the positive k. So I will write plus 6k. So now let me write this in order. So this is minus 6i minus 3j, and this is minus 4k plus 6k. So this will give us plus 2k. So this is plus 2k. So we got that same position vector. This is minus 6i plus 3j plus 2k. So these are the two methods to obtain, to write the position vector between any two given points. So now let's find the magnitude of this position vector. So the magnitude is, let me find it directly. So the magnitude will be the 6 square, the square root of the sum of the squares of the component. So this is 6 square plus 3 square plus 2 square. So this gives me 7. So we can write that this is T2 divided by 7. Now let's multiply this fraction with each component magnitude. So that will be T2 Cartesian vector. This is minus 6 divided by 7 T2 I minus 3 divided by 7 T2 J plus 2 divided by 7 T2 and K. So this is the position vector, the Cartesian vector representation of T2, which is acting from A to C. So in the same manner we will find the Cartesian vector representation of T3, which is acting from A to D. So again we can write that this will be T3 times the unit vector from A to D, or we can say that the position vector from A to D divided by the magnitude of the position vector from A to D. This is T3. And now the position vector from A to D is, from A we need to travel 4 meters in the negative k, so I will write minus 4k. So from here we need to travel 4 meters in the positive x direction, so I will write plus 4I, and then from here I need to travel 3 meters in the negative y direction, that is 3 meters in the negative j. And then once I reach the base of the pole, I need to travel 4 meters in the positive z. So that is 4 meters in the positive k. So as we can see that this is again plus 4k and minus 4k, so this will give us 0k. So again we can see that point A and D, they are at the same height. So that is why we get the k component equals to 0. Since the height of this point A, the knot, is 4 meters and the height of the pole is also 4 meters. So then again we have to find the magnitude of this. So the magnitude is the square root of the sums of the squares. So this is 4 square plus 3 square plus 0 square. So again it gives me 5. So this will be T3 divided by 5. So T3 Cartesian vector is equal to, again we need to multiply with each component. So this is plus 4 divided by 5 T3I minus 3 divided by 5 T3J and 0K. And at the end we are given that the traffic lights have a mass of 15 kg. So this means that its weight is going to act vertically downward. So the weight is acting in the negative k direction. So we can represent that weight as a Cartesian vector. So weight as a Cartesian vector can be written as, so the mass is given, so the weight magnitude will be mass times g. So this will be 15 into g, which is 9.81, and this is acting in the negative k direction. So this is 15 multiplied by 9.81. This gives me 147.15. So this, from this we can say that the weight has 0 component along I, 0 along j, and minus 147.15 in the negative k. So now since the traffic light is in equilibrium, so the sum of the forces along x, y and z, that must be equals to 0. So we need to apply the summation of forces along x equals to 0. So we need to add up all the I components of T1, T2 and T3. So let me write that the I component of T1 is plus 3 divided by 5 T1. The I component of T2 is minus 6 divided by 7 T2, and the I component of T3 is plus 4 divided by 5 T3, and this must be equals to 0. Similarly, we have to apply the summation of forces along y equals to 0. So now we have to add up all the j components. So the j component of T1 is plus 4 divided by 5 T1, the j component of t2 is minus 3 divided by 7 t2, and the j component of t3 is minus 3 divided by 5 t3. This is minus 3 divided by 5 t3. So this will be equal to 0, and similarly the summation of the forces along the z-axis, that must be equals to 0. So we need to add up all the k components. So the k component of t1 is 0, so we will write that 0, and then the k component of t2 is 2 divided by 7 t2, so that will be plus 2 divided by 7 t2, and the z component of t3 is 0, this is plus 0, and we have this k component of the weight as well, right? So in case of the summation of the forces along x and y, the x and y component of the weight is 0, so that is why we have t1, t2 and t3, t1, t2 and t3 in both of these equations. But in the last equation we will have this minus 147.15, this must be equals to 0. So now in the last equation we have only one unknown, so this will give us t2. So from this equation, if we remove these zeros, so we are left with this equation, and from this equation we can write that t2 is equal to 147.15 into 7 divided by 2. So this will give us t2. So let's find t2. This is 147.15 multiplied by 7 divided by 2. So this gives us t2 approximately equal to 515 newtons. Since this weight is in newtons, remember that this weight will be, the units of this weight will be newton, and similarly from this equation we will get the units of t2 equals to newtons as well. So t1, t2 and t3 will also be in newtons. Now we know t2, so we can write this equation and this equation in terms of t1 and t3 since t2 is known. So let me write, let's say that this is equation 1 and let's say this is equation 2. So now let's simplify equation 1. So from equation 1 we can write that this is 3 divided by 5t1 plus 4 divided by 5t3, and if we bring this t2 term to the other side of equation, so we will have plus 6 divided by 7 t2, and now we know t2 value, so let's put that t2 value, which is 515. This is 515 newtons. So this is 515. So and we want to simplify is we want to get t1 or t3, since in both of these equations now we have two unknowns. So let me write equation 2 as well. So this will be equation 2. Let me write equation 2. So plus 4 divided by 5t1 minus 3 divided by 5t3, and if we bring this t2 terms to the other side of equation, so it will become positive, so we will have plus 3 divided by 7 t2, and t2 is now known, which is 515. So now since we need to solve both of these equations simultaneously, so we need to cancel out one of the unknown. So if we want to cancel t1 by adding or subtracting equation 2 from 1, so we need to make the coefficient of t1 equal, right? So for that, if I multiply equation 1 with 4 and if I multiply equation 2 with 3, so in that case we will have the coefficient of t1 equal, right? So let me multiply this whole equation with plus 4 and this whole equation with plus 3. So now this will give us 4 into 3 is 12, so we will have plus 12 divided by 5 t1 Now multiply this, so this will be 16 divided by 5 T3, and similarly we need to multiply this 4. We have multiplied this 4 with the whole equation, so we will have 4 into 6 is 24 divided by 7, and this is 515. Similarly we now need to multiply this plus 3, so this will be plus 12 divided by 5 minus 9 divided by 5, this is T1, 9 divided by 5 T3, and this is 9 divided by 7, 515. Now let's subtract this modified equation 1 from modified equation 2. So now let me write this equation here. So this is that equation. Now we need to subtract that equation. So we will reverse the sign. So this is plus into minus, plus and minus. So now this will cancel out, and here we will have we need to add up both of these coefficients since we have minus and minus now. So this will be minus 9 divided by 5 minus 16 divided by 5. So we get minus 5. This is minus 5. And now we need to add up these two numbers, right? So since this is 515, this is 515, so if we add up both of these coefficients, just like this T3, so let me add up these. So this is 9 divided by 7 and minus 24 divided by 7. So we get minus 15 divided by 7 into 515, since we have added only the coefficients. And this is, remember that this is minus 5 T3, right? So now minus when cancelled out, and we can write that T3 is 15 divided by 7, 515. This is 515, and here we have 5, so we need to divide both sides of the equation by 5. So this is, we can say that this is 15 into 515 divided by 7 into 5. So this gives us T3 approximately equal to 221 newtons. So now we know T3. So now once we know T3, we can put that T3 in one of these equations, and that will give us T1. So now from this equation, let me further modify this equation. So from this equation we can write that 3 divided by 5 T1, this is equal to 6 divided by 7 into 515, and now we need to bring this term to the other side of the equation, so this will become minus 4 divided by 5 into T3, and now we know T3, which is approximately equal to 221. So this is 6 into 515 divided by 7 minus 4 into 221 divided by 5. This gives us 9262 divided by 35. So from this we can say that this 3 divided by 5 T1 is equal to this fraction, and to find T1 we need to cross multiply this 3 divided by 5. So from this we can say that T1 is equal to 9262 divided by 35 into 5 divided by 3. So we need to multiply this answer with 5 divided by 3. So this gives us 441. So T1 is approximately equal to 441 newtons. So we were required to find the magnitudes of T1, T2 and T3 when the mass of that traffic light is 15 kg. So now T1 is 441 newtons approximately, T2 is approximately 515 newtons, and T3 is 221 newtons. So this is the solution of this particular problem. I hope it will help you in your learning, Let me know in the comments if it helps in your learning. Also subscribe Engineers Academy for the solution of such more problems related to engineering statics and dynamics.